In this exercise, we will continue working with the Moore-Penrose pseudo-inverse, and in particular, we will demonstrate that the pseudo-inverse equals the left inverse for a tall matrix, and the pseudo-inverse equals the right inverse for a wide matrix. Now, in both of these cases, you need to make sure that the random numbers matrix you are using to test this, to evaluate this exercise, is full possible rank, so full column rank or full row rank. And that's because you will need to explicitly invert A transpose A or A transpose for a wide matrix. So create a tall matrix and compute its explicit left inverse using this formula, and then compute the pseudo inverse of that tall matrix. And then you want to see that these two matrices are the same, of course, to within some reasonable degree of precision. And then, repeat that for a wide full row rank matrix. I think the code for this exercise is fairly straightforward. This is really just a good reminder to you about the relationship between the pseudo inverse and the one-sided inverse. So here we have the explicit left one-sided inverse for a tall matrix, and it's the inverse of A transpose A times A transpose. And then I compute the pseudo-inverse of matrix A, subtract those two matrices, and we expect to find all zeros, a matrix of all zeros, because these two are equal to each other. Okay, and then, repeating for a wide matrix is almost exactly the same. You just have to be mindful that it's A times A transpose that we invert, and the A transpose is pre-multiplying instead of post-multiplying as with a left inverse. Okay, and then, so that these are all zeros, I think this is a pretty straightforward exercise.